So synthetic data, it really what it is, it's artificially generated data. So it's not data that you're actually sampling from the real world. It's artificial data. But the important thing about it is that it mimics the kind of the statistical properties and patterns of that real world data. And, so that anything that is correlated in the real world is correlated in the synthetic data. It's almost like spy versus spy. You have a generator that's generating all of these potential candidates for synthetic data, and you have a discriminator whose job it is to detect, is it real or is it not?
I'm really excited to bring back Ed Martin, where we're going to be talking today about synthetic data and recapping a little bit over our conversation for digital twin, digital thread. I'm also excited to say that we may be streaming on YouTube today, but as always, maybe this is going nowhere and we're just going to post a recording at the end of it. So yeah, let's have fun. Ed, you want to do a quick introduction about yourself?
Yeah, absolutely. Thanks, AJ. So I have been around for a while. I worked in the manufacturing industry for a number of years. And then after that, I moved over to Autodesk and then Unity until starting my own consulting company last year, focusing on digital twins. Everything I've done throughout my career has kind of converged on this topic of digital twins. I feel lucky to be at this point in time right now working on it.
Yeah, and I think digital twin is the coolest thing about it. So what's a good 30-second recap of what a digital twin, digital thread is for the people who didn't see our previous talk?
Yeah, absolutely. So and I would say for anybody who's really interested, go back to the previous talk. But, the formal definition is a digital twin is a virtual representation of some real world object or system synchronized and updated at some specified or at some frequency. And, effectively what it is you've got a virtual representation of something that is out there in the real world, and it's meant to represent a specific period of time in a system or a specific unit of something. And it's kind of like the brain in a way that knows what's going on in the real world, and it's periodically updated. And a digital twin can be live and connected and knowing what's going on at any point in time, or you can unplug the digital twin from the real world object or model, and you can use it to run what if scenarios. Okay, the system's at this state. What if I did this? What if I did that? What would be the outcomes? And it's when we start getting into some of those hypotheticals, as well as the development of a digital twin in the first place, is where we get into the topic of synthetic data. Because synthetic data in so many ways is really integral to the creation of many digital twins.
Yeah, we touched upon that last time, and some use cases that I think we mentioned that I find really interesting for digital twins. So of course there's the manufacturing use cases, right? Especially some of the stuff that I used to do in augmented reality, where we're working with the virtual representation of a aircraft engine, right? But then also having things like simulating supply chains, right? What if scenarios? What if this shipment is later? What if some quality control issue has here? So being able to do that. And then, some other things that I recently seen about things like using digital twin in financial services.
Yeah.
Right. So how do we begin to identify fraudulent behaviors, right? And be able to start tagging them and identifying them. And yeah, it all comes down to data. So last time we talked about getting actual data from like IoT devices and sensors, or it could be reports or anything like that. But then we talked about dummy data, and now we're going to talk about synthetic data. So why don't we just start there? I think a lot of people probably know what dummy data is, right? We've all built it, made it in some form, Jane Doe, whatever. But yeah, let's talk about the difference. So what are we even talking about with synthetic data?
Yeah, so synthetic data, it really what it is, it's artificially generated data. So it's not data that you're actually sampling from the real world, whether it's from a sensor or anything else. It's artificial data. But the important thing about it is that it mimics the kind of the statistical properties and patterns of that real world data. And, so that anything that is correlated in the real world is correlated in the synthetic data. So it is completely plausible data, but that it's data that just is not actually obtained from the real world, but could be real in a way. And, I would just say there are a lot of different ways to create it. So I don't want to, there's no one right way to create synthetic data. We'll get into that more here later on. And there's not just one kind of synthetic data. It could be images, it could be video, it could be 3D models, it could be tabular data, it can be time series data, it could be anomaly detection events, sensor inputs, environmental conditions, it could be human behavior. There are all sorts of things that could roll into being synthetic data. And I'll add, it's not a substitute for real world data. I mean, sometimes, and we'll talk about this too, it has to be simply because you don't have the real world data, but it's useful often as either an augmentation of real world data or as almost like a prequel where you use synthetic data until you have real world data. So it's really, it's an adjunct. It's not a replacement. It's an adjunct for real world data.
Yeah, I am glad that you went into the different types of data because the term data itself is really broad, right? Anything can be data. So it's good to know that, when we talk about synthetic data, it could be all of these different things that the system requires.
Yes.
Right. And I think that's really, really interesting. So, when we think about synthetic data versus the data that somebody's just coming up and obfuscating through, creating some back-end script to hide first names and last names, like, why is synthetic data different than that?
Well, you're saying, why is it different from dummy data in a way?
Yeah.
Or why is it
the things that
obfuscated or dummy data? Well, I mean, first of all, if you're just obfuscating data, real world data, it's still real world data. It's maybe anonymized, PII, personally identifiable information's been removed or something of that nature. But at the same time, it's still real world data. And it's different from dummy data because, dummy data, as we've kind of talked about, it's just, in a way, it's the data version of white noise. It's just random. Might have a Gaussian distribution. It might have like a square form distribution equally probable throughout a range or something like that. But it's still, at the end of the day, there's, technically speaking, there's no information in dummy data because it is exactly that. It is statistically random, insignificant data. And so if you're either anonymizing real world data or just generating white noise, neither of those are really, the anonymized real world data can be useful for things like algorithm development, but you only have what you have. You don't create new data that and resample it. Whereas with dummy data, you can create all you want, but it's useless in this context. It's not, I'll just say, it's not completely useless because sometimes even in the context of synthetic data, you might want to take synthetic data and add noise to it to generate things like real world sensor noise or something. So even dummy data can be useful, but by itself, it's useless.
Yeah. And I like that you mentioned PII because this is one of the things that excites me the most of using AI to generate synthetic data. And we'll get into some of the methods for that. But there's been countless situations where you had teams of engineers who took real world data, anonymized it, but forgot something, right? Somehow you're able to reverse engineer what they did and then start to identify the actual data that it was based on. And now you have all sorts of security and privacy issues. Data is leaky. Everything is leaky. Systems are leaky, right? So when we talk about generating synthetic data that feels in actually real data, right? We're getting away from the real world data that could be traced back. I think we ended the last conversation, we talked about hallucinations and synthetic data, right? And it's like, well, yeah, it's all hallucinated, but it's hallucinated within guardrails,
Exactly.
right? It meets a standard. So
it's more like a lucid dream as opposed to one of those crazy dreams where you wake up and wonder what it was. It's still real.
I love that.
Yeah.
I love that. So yeah, let's talk about how AI is playing a role in the next generation of synthetic data.
Sure. So where do you want to start with that? You want to talk?
How do we even generate it, right? What are the different methods, and with different types of data, where do we go to get started? How do we begin?
Yeah, I think it's a really good question. And I think first of all, I just want to say, not everything is going to be based on AI. I think a lot of the techniques for generating quality synthetic data at scale obviously include AI, but I want to step back to the basics, because really at the end of the day, synthetic data is merely data that is realistic, but not real. So it behaves as if the real world would. And so one of the things is, if you have a simulation model for a system, and you can, through classical techniques, you can model the behavior of that system, and say, for example, you want to create a control system for that system. It's something out there in the real world, or you want to create some kind of diagnostic system or something like that. Well, you can run that simulation model over its valid operating ranges. You can do things like simulate sensor faults. What if this signal goes dead or something of that nature? And you can actually just kind of, I would say almost from a design of experiments perspective, generate the data using completely classical techniques. That's a valid way of generating synthetic data. And in many ways, if you really understand the behavior of the underlying system well, it's a completely valid and almost preferable way of doing it. I'll tell a war story here. Back, 25 years ago, roughly, we were doing systems using Simulink and what are called DSpace controllers. And that's exactly what we were doing. We developed a model of the system we were controlling. We developed the symbolic model of the control system, and we would use synthetic data all day long to refine the development of control and diagnostic systems. And there was no AI involved in that at all. The other non-AI based approach is, can start with non-AI at least, is using things like procedural authoring tools. So node-based tools. You can do this in a lot of different software packages. Houdini's common for it, but there are others as well. And you've got parameters attached to all those nodes. You can essentially vary those parameters within realistic ranges and then generate a variety of outputs there as well. So that's another valid way of generating, common for things like surface textures or the like. But then we start getting into the AI methods, which I will also add can be used in combination with. So you got GANs, and AJ, please jump in too, especially if this is an area of strength for you. But with GANs, it's almost like spy versus spy. You have a generator that's generating all of these potential candidates for synthetic data, and you have a discriminator whose job it is to detect, is it real or is it not? Virtually everybody's taken a test at some point. Is this image real or is this image fake? And see if you can tell which is which. And a discriminator is effectively doing the same thing. It's trying to pick out the flaws to say, no, that's not real. And by competing against each other, these two, the generator and discriminator, effectively force each other to up their game. And by doing that, you can eventually get to the point where you've got a generator that's very good at generating synthetic data within the specific domain that you're applying it to. Then you've got variational autoencoders. I need to speak more slowly. What those do is those take data and they encode them. So, and you're going to want to start with some real world data, but you encode that into a lower dimensional space and then decode back into the original data distribution, and you can effectively create new data distributions that way. But by learning the probability of various things, as well as the correlations between different parameters, you can effectively generate new data that is realistic.
I think for VAEs, I think, sticking with the type of example you had for GAN with the spy versus spy, which is exactly the same example that I used in my present, but it was more like the art forger and the art detective, right?
Yeah.
For VAEs, I had a challenge understanding the lower dimensional latent space concept, because for me, it wasn't connected.
In a way, like how
exactly. So, I guess the best way that I could think to explain it to an audience not familiar with it would be, imagine watching a movie, and then your job is to communicate the essence of the movie to somebody else in as few words as possible. We're like a summary.
Yes.
And then that's what you're thinking of in your mental latent space. And then you, as the recipient of that, you decode that and say, okay, do I understand what that movie was? And then try to replay it. And then I say, no, that really wasn't the point of the movie. And you say, well, okay, you got to try again, right? So that's that capturing the essence or the fundamental theme or meaning of the data that pushes us forward into something else.
Yeah, no, I think that's a great point. You could have something as simple as a scene in the movie where, the cat jumped from one window ledge to the other. Within that, you've got a lot of different things you could do. It could be a tabby cat. It could be, any kind of cat that would make that jump as the window ledge brick or something else. All of these things, you still got some core idea, but you can expand it into a lot of different variations on a theme. And a VA can kind of do that. And then I would say the last major method that's used is diffusion models. And so anybody who's used like Midjourney is familiar, because that's a diffusion model based system they're used a lot for image generation. And they're effectively, what you're doing is they're taking the original signal or scenes or data, adding noise to them, and then learning how to essentially decode the images from the noise in a way that they can get back to multiple variations of an idea from that noisy representation. And again, I'm sure you can do a much better job of explaining diffusion models than I can, AJ.
I think you did a great explanation of that. My thinking around diffusion models, I kind of think back to the beginning of how is this labeled originally, right? Let's take that example of a cat. And I guess, at this point, we matured so much in the technology that we have large language models overlaid on top of images that are tagging images automatically. Like, we've just gotten so far. But if we were to take it all the way back to its early stages, it's, somebody was going tagging a cat is a cat. Here's a picture of a cat, but it didn't say like, this is the cat in the image.
Yes.
Right? At least that's my understanding. So now you have, let's say, a million pictures of a cat, and it's basically, the algorithm is going through and saying, okay, well, what are the similarities here? And over time, it's like, oh, things that represent this is the cat, right? Yep. It's not the brick. It's not the thing where maybe, you get into more complex categories. Here's a cat on a brick facade. Yep. Here's the cat running through a field, and like, it has to learn to differentiate that. So I just think it's the coolest thing where it's, over time, it's like, oh, okay, I can pull out like this subset of image data and say like, this is a cat because somebody told me this is a cat.
Yeah. I've learned what catness is.
Yeah.
In a way. Yeah. And you also hit on something I think is important about the way that people are now layering and combining these different techniques. And I think that can also be very useful for synthetic data, depending on the types of synthetic data that you want to use and your desire to, say, potentially combine synthetic and classical techniques or combine synthetic or AI-based techniques together in a way that, gives you an edge in the creation of that data. And I think the one thing that's fair to say is it's a pretty rapidly evolving field, and there is no one best or right answer. It really depends on what kind of source data do you have, and what kind of data are you trying to generate, and that's where the expertise comes in, is figure out how to go from A to B.
Yeah. So let's talk about that real quick, because the expertise is absolutely necessary. I like to think of things as, we all do garbage in, garbage out.
Yeah.
Right? So the lower quality your real world data or the data you're modeling off of, of course, you're just going to get horrible quality coming out because, the algorithms don't actually know what they're looking at.
Yeah.
Right? And that's the huge thing. Anybody who goes on the ChatGPT subreddit, I don't know if you like Reddit, I'm on Reddit way too much.
Yeah, I know. It's a blessing and a curse. It's both. Yeah.
Yeah. But so you always see these examples on any LLM subreddit where it's like, oh, look, ChatGPT can't understand, the answer to this question. It's like, yeah, because it's not actually thinking.
Yeah.
It's predicting a token, right? So basically what you're doing is you're finding a way to traverse the end space using language, but it doesn't know that. And people always see it as an I got you. Right. I got you, ChatGPT. You're not able to tell me, I think there was one today, how would you say 0.0000658, some number, how would you say that?
Yes.
And it couldn't get it right. And it's like, gotcha, it's not so smart. It's like, yeah, it's not smart. So all of that to say, let's talk a little bit about garbage in, garbage out. Where do the experts play? What are the pitfalls that we need to avoid when we're thinking of synthetic data?
Yeah, absolutely. So I think there are a number of potential pitfalls. And so, and they're not all, it's not predestination, they're not guaranteed, but things just to be aware of so that if you're not actively looking out for these things, your chances of running into these problems are much greater. So the first one is just that the synthetic data doesn't cover the full range of variability that you're interested in. So you get blind spots, and that could be depending on the nature of the real world data that you're using as kind of the grist for the mill, if you will. If you're not explicitly finding a way to expand on that data or explore the corner cases of that data, you could end up with just absolute blind spots. I think we talked in the last session about autonomous driving, and I used it effectively. A couple of things. First of all, if you take data from a car that's, say, driving down the expressway or through the city or something, 95% plus of the time, the data that you're getting from that is useless because there's no new information. A car just driving between the lanes and no obstacles in the way or anything else doesn't present any kind of a challenge for the vehicle. You're not learning anything new. You're not presenting any new challenges to the system. So in a lot of ways, one of your goals is to make sure that you're covering those things that only happen. What was the number you said? 0.00006% of the time or something. But it can happen. You want to make sure that you're capturing some of those things. So that's a risk that you don't capture that. Another risk is that the synthetic data doesn't really represent the real world. You've got a boiler, and you turn on the heater, and the temperature goes up and everything else, and it's a closed system. And then your synthetic data shows that the pressure isn't going up. Well, unless you're explicitly trying to emulate a pressure sensor failure, then your data's not correct. So you have inaccuracies that just fail to represent how the real world will behave. And of course, if you're relying on that to design systems, you've got, you're missing a leg of your stool. You can have bias in the data. So, and then that kind of gets the garbage in, garbage out. If your source data is heavily biased and you're not controlling for that bias, and a lot of times in AI, bias gets into like demographic factors and such with image discrimination, but frankly, bias can exist in any kind of data, and it can be unintentional, just like it is with people. But if the bias is there and you're not controlling for that bias, it can slip into your synthetic data.
Yeah.
I talked about missing outliers. There's absolutely the garbage in, garbage out noise in your source data. So if you've got flaws, missing fields, the data isn't normalized correctly. Somehow it's data structures are interpreted wrong, garbled information in, completely throw you off. And a couple of other things, if the underlying data, depending on what this gets into all kinds of gray zones, but depending on what you're doing with the data and depending on the source of the data, if it has information that is copyrighted, or we talked about sensitive personal information or something, then the synthetic data could also potentially be impaired for your usage, depending on what it is you want to use it for and the associated rights and restrictions on that source data. Final thing is, I would just say, and this doesn't get to the quality of the data, but depending on the quantity of synthetic data you want to generate and the methods that you're using to generate that data, it can be expensive. It can be cheap. It can be expensive. There's a huge range, but you start to get into a marginal utility factor of, okay, how much data do I need? How much range of data? Everything else. Is it better to do synthetic data or real world data? Generally, synthetic data is cheaper, but you have to consider the potential cost of it, depending on what you want.
Yeah, I like what you said. I liked a lot of what you said. One of the things that stood out to me, the corner cases of the data, right? Dig in a little more. What do you mean by that?
Yeah, so corner cases are, information theory is, effectively when something unexpected happens, there's information in it. And, effectively it's when your synthetic data has something in it that you're not necessarily expecting, but is realistic. I used the example of a sensor failure before, so a corner case would be a sensor failed. Or maybe, I don't know, I'll go back to our autonomous driving example, and you've got, say, just a camera sensor, nothing special, but you get a bug that hits it, and now it's splatted all over the camera, and you're getting a signal, but it's not the signal that you would like to get, or maybe it obstructs part of the field of view of LiDAR or something of that nature.
Yeah.
What's that look like? You're driving along and the sun's setting and you get sun glare into a camera. All sorts of things can happen that you're not necessarily anticipating, but any system, whether it's a production system that's running for 20 years or it's a car, driving through its 200,000 mile life cycle or something of that nature, all kinds of crazy stuff's going to happen, right? And so it's just making sure you're capturing those examples of things that you either want to be able to detect and account for in your control system, or maybe you're training a perception system and you want to identify when, people in balaclavas and machine guns are trying to scale the walls or something of that nature, that you need to be able to pick out those unexpected examples.
It's almost like this reinforces the mentality that's happening. I mean, it's been happening for the last, 10, 15 years, but data is king.
Yeah.
Right? Attach a sensor to everything, save everything you need, every signal you can get. Because you don't know what we're going to do with it. Yeah. But we might need it. So hold on to that data.
Yeah. If it's available, there's certainly a question of, if you want to go around and instrument everything, you're building a new plant, you want to let's throw instruments at everything. Okay, that's not necessarily advisable either, just because, first of all, it's expensive. Just capital expenditures, you're going to spend more on sensors and more on installation. but also operational expenses. Whenever you add something to a system, then it can go bad and somebody has to go out and repair it or replace it or something. You don't want to go overboard, but certainly if you've got the data, you don't want to throw that data away, because you might have, 5 years ago, we probably wouldn't be having this conversation about synthetic data. But the people who took that data 5 years ago and they have it in their data historians or whatever, sure glad they have it, because now it can be very.
Yeah. I almost wonder if there's a way to use VAEs to compress all of that data, because data storage is becoming increasingly large problem.
Yeah.
Right. So is there the opportunity, and I'm sure people have figured this out already, but basically grab the essence of that data so you could say, all right, we can put this in cold storage or, something, a way that is going to be cheaper to archive it, and we'll just go from there. Like, AWS has released multiple tiers of S3 buckets so that you can archive data, but at the end of the day, it takes money, space, energy to keep just the bits magnetized. I guess going off on a little tangent here, I remember recently reading an article. I never thought about that energy expenditure required to just keep data on a magnetic platter somewhere. We're just something, right? You gotta keep it.
It's absolutely true. And so there is, the economic cost of just, and it's kind of counterpoint to what we just said earlier, but the economic cost of just taking all that data and just pouring it. And it's kind of like that, a junk drawer, that the ever expanding junk drawer of stuff that you've got going in there. And eventually, even though cold storage is relatively inexpensive compared to hot storage, or, like you said, there's multiple tiers, but even the coldest of cold storage, if you throw enough terabytes or petabytes of data in there, it's going to cost you. And so, it's a very reasonable point. I hadn't thought about the question of using VAEs for that, but fundamentally, that is what they're good at. So that actually could be a really, use the data, effectively develop a compressed representation of it. Now, going to have some forethought on that, because you might find out that you've compressed out some of the interesting data. It can happen.
That's the problem. Yeah.
But it's a really good point.
Yeah. So, that goes back to having the experts that can understand and work with, manipulate that data. You still need it. And I think this is the counter of the argument of AI is going to take over the world, and it's going to take jobs.
Right.
And, I have seen some examples of where people simulating these complex systems have been able to use AI to identify new data points that, especially in weather forecasting, right? And simulating the environment, they've been able to use AI to kind of look at it and say, oh, there's an entire ecosystem here that we haven't considered.
Yes.
But again, that AI is trained on something that's predicting, next token or trying to identify. It's not going to let you think around corners.
Yeah, it's a really good point, because I think what AI is incredibly good at is detecting, discovering even patterns in massive data sets, just more massive than any human being could hold in their head, no matter what. But at the same time, it isn't good, and it's the meaning elements of it. With that, most AI techniques don't really come in with this understanding of prior knowledge and mental frameworks and the semantics, the meaning behind things. It's more of just kind of a dumb recitation of facts, if you will. And so, that idea of generating novel insights, AI is both incredibly useful at mining huge data sets to be able to surface these patterns that we wouldn't otherwise find, but incredibly weak at really being able to develop those insights itself. So to me, the real magic happens is when you get the ability from human perspective to understand concepts and apply novel insights to the ability of AI. It's a power tool for the brain, if you to be able to identify those patterns in a way that no person could.
Yeah, exactly. And I've used the term, I think more and more, I think I use it every day at this point, but instead of AI being artificial intelligence, it's really augmented intelligence. It is a power tool for people to use. And yeah, I absolutely love it to be able to look at a wide swath of data and then start providing some inferences on it or summarizations or relating the information in ways that either would take me a lot of time or a lot of effort, or, it's just something I can't keep tabs on. I think medical information is huge.
Yes.
They keep saying, the LLMs can diagnose these outlier diseases a lot more efficiently. And it's like, yeah, because nobody is going to remember, it's like Dr. House, right? When he was a thing, like nobody's remembering all of these things. So it's basically, scanning through all of the parts of a system and saying like, here's where I'm seeing the same indicators come up or the same patterns, and let me output that to you. But then we still have to translate that and figure out, does it make sense? Does it not?
Yes, exactly. Yeah, no, I think that is absolutely perfect. I think a lot of AI systems, that my admittedly flawed analogy here is it's like an over-eager intern who has zero domain knowledge, but is willing to work incredibly hard and is going to come back to you with an answer no matter what, even if it's wrong. But it's that idea of really, I love your term of augmented intelligence, where it's really about using the tools to augment the ideas and the skills and the concepts and such that we already have, not to replace them.
Yeah. It does make the gap larger, though, I think, for people who are just entering into a professional track, because now they gotta compete with these huge, capable knowledge repositories, and they have to get ahead of it. So yeah, I definitely see that it's adding a gap there. But it's a tool. Like, we need to teach how to use this tool, how to do simulations, how to think through synthetic data. I think it's great. One of the things you mentioned is bias. And oh my God, we've been talking about bias forever and ever and ever, because it's always an issue, even if you don't think it's an issue. So what are some of the approaches that you're seeing to work to combat bias and really put a framework together around transparency and accountability, things like that?
I think it's important. It's a good question. I don't know if I've got a great answer for you, but I'll give you my best answer. I think it's important up front to really think through what are the possible sources of bias, and importantly, what are the possible sources of bias that we're really worried about? Because some biases are essentially they're gonna come out in the wash. It's not really gonna impact the final result. Some biases could be, highly problematic. So if, for example, and I'm going to use a completely benign example of bias here, but we talked about just not having enough distribution in the data set. If you have sort of a half-hearted attempt to gather real data and then use that half-hearted attempt of real data to train a synthetic data system, and I don't know, I'm going to use a contrived example of you're designing a perception system to, identify people of risk coming in the front door of a shop or building of some kind. If all you do is you have a camera standing at that door, nobody ever walks in the door, and you're never able to identify anything, that data is completely and utterly useless. So you need to say, all right, now to make the example less benign, what characteristics do you use to identify somebody who's threatening? Do you look for them carrying a weapon? Do you use other methods? These are things that you have to really go through and say, all right, let's think about what bias could get injected into this, either intentionally or unintentionally. And let's expand our generation of synthetic data. Let's expand our capture of real world data. Let's expand our generation of synthetic data, and let's put in some guardrails to explicitly control for that bias. So I think it's really more about just understanding what the potential sources of bias are up front before you go any further.
Yeah.
Excellent. I didn't think it'd be a perfectly satisfying answer, but I'm curious on your perspective on that, PJ. What do you think?
Yeah. So to your example, I wanted to just touch on really interesting because that gets into some of the ML techniques around structured and unstructured learning. And, you correct me if I misspeak here, but, structured learning, you're basically processing already labeled, organized, well-formatted data. And then
That's a cat. That's a dog.
Yeah, it's a cat. It's a brick. That these are credit card numbers if it's a financial thing.
Yes.
But then unstructured learning, you're basically saying, hey, here's a bunch of video data. So let's take your example of the threatening behavior.
Yes.
Here's a bunch of data, your video data, people coming in and out. Do something with it. I have no idea. And the ML model's job is to then do things like clustering and saying like, okay, a subset of all of these look like this, but I don't know what it is. And a subset of all of these look like this, and I don't know what that is, but I know that there are patterns here. And, at the end of that, person is going to take that information and then say, okay, what does it mean? That group of people is threatening. That group of people is not. And it's even after all of that work, here you're entering with bias again, because you have the person saying that this group looks threatening to me.
Yes.
Maybe it's because whatever the reason is.
Yeah.
It falls on the person labeling the data at the end.
Yes, exactly. And it's especially helpful, I think, if you can come up with some sort of objective measure to kind of help filter out the bias, that most, of course, I'm stretching my contrived example to ridiculous levels, but I don't know what else to do here. But they've got a huge amount of data, and I don't know, you're looking for bank robberies, okay, if you've got video evidence from every bank in the country for 10 years, there are going to be some bank robberies, and can you pull anything out of that? And then you can identify there's a bank robbery here. Or say you've got vehicle data under these conditions, something is more, there's an event that happened and it's indisputable what the outcome was. And if you can tie those outcomes to the sources, then you maybe come out with something that eliminates the bias. I think the key lesson is you have to think about up front. I'm going to change my answer a bit. Not only what are the sources of bias, but what methods can we use to help drain the bias out of the source data, or to, come up with objective measures as opposed to subjective measures.
Yeah. Yeah. And I see a lot of the big AI players coming up with their framework, of responsible AI.
Yeah.
And explainable AI, right? We were talking about explainable AI like 10 years ago. How do you pull back the covers and say, what is actually happening as information goes into latent space and it comes out with a determination? It's like, we need to understand the process. So yeah, like I don't think that I have a best answer for this, but things like explainable AI, things like censorship models are all trying to attack bias, but we've seen what happens with censorship models, because that thing itself
can introduce bias.
Yeah. And then you have things like, tell me about the history of, X, Y, and Z, and it starts putting it out as, oh, you know what, this is refuted and I can't explain it any further. So I don't know if there is going to be a 100% fit solution. Another thing that we're seeing now is AI using AI to then validate and verify what AI is putting out.
Yes.
Right. So creating a system that can have a little more context and have more of those guardrails to then weigh in on what a lower level model is trying to produce as an output. So, what is that meme? It's like, it's going to be AI all the way down.
Yeah.
AI.
But I think the important thing is you've got to make sure that there's a robust verification loop throughout this, because, when I was starting out as a young engineer and I was actually doing simulation and modeling work for some, the very first lesson I learned was, you might fall in love with your model. It's great. It's awesome. It's everything else. But you got to go check it against the real world. Does it work?
Mm-hmm.
Where are the flaws? Because there are always flaws. Maybe it's fundamentally pretty good and sound, but it doesn't handle certain spaces well. I mean, why did Einstein come up with quantum mechanics? Because he was like, well, there's some problems with the data that we have. Some things don't work right. And then okay, why don't they work right? And that led to the discovery of a new theory. But unless you're constantly testing what you've got against, unless you're constantly verifying it, finding out where it works and where it doesn't work, it's easy to fool yourself. So I think that's especially important as we're doing a kind of an AI top to bottom stack, that the verification is really a strong part of that.
Yeah. And there's, as we get into these more complex systems, the attack surface in the cybersecurity world continues to increase. And, as we're talking about it, I feel like this is another great topic to do some research in, is data injection to basically disrupt synthetic data.
Yeah.
Right? How can a bad actor start to inject bad quality, high bias data into a model so that they are now controlling the outputs of it in some way, right? There's already a lot going on about how easy it is to social engineer LLMs. What was the example with, it was a car dealership that had a chatbot it wasn't chatbot, but it was an agent. And the person convinced them to sell a car for $1 and basically say, this is a legally binding agreement. You got to run it.
Thanks for saying credit to the person who figured that out too.
Yeah.
But it's a great example. And, and I think you're right, because effectively what you're getting to is, as humans, we demonstrated as a society that we're sometimes susceptible to disinformation. And you can argue what's disinformation and what's not. I won't go there, but it's, we're susceptible to disinformation. So are AI models. And so anybody who makes a concerted effort to inject bad data, you can end up corrupting the model. And that's a really good point. It kind of points to the need to have a red team approach just to make sure you've got robustness against that.
Yeah. And we were talking last time about the chaos monkey concept, and especially in autonomous vehicles, right? What happens when somebody puts a cone on the hood? How do you handle that?
Yes.
So now we need the same thing for the data. What happens when bias is injected to your data? Did you discover it? Did you identify it? Did you recover from that? Or did it just find its way in and propagate bad outcomes?
Exactly. And, and what are you using? Certainly this is true for LLMs. What are you using as your base model? What kind of fine tuning you're doing? What data are you using to fine tune it? All those sorts of questions. You kind of think almost like what's the chain of custody of this thing?
Yeah.
Where you got it and how you're applying it.
Yeah. Oh, that's really interesting. The chain of custody for that specific data. And I know blockchain is supposed, people have been talking about blockchain. Oh my God, I'm rolling my eyes so hard right now. But anyway, one of the ideas behind that is to have that chain of custody throughout the ledger and have that shared with everything. But even that, if you can get to a sensor level and start putting bad information through the sensor, there is a path towards injection on that. And
yes,
it's just more and more that we have to take care of it. So, with all of that said, and, where the conversation is going. How do companies get started with synthetic data?
I think the first thing is, it's kind of like with everything. What problem are you trying to solve? Because you have to start with the problem. And, then you need to think about, with synthetic data, what is, okay, I've got this problem. How can I solve this problem? Is synthetic data a part of that? And then you get into the realm of, you need to pull in somebody. You need to hire somebody or have somebody on staff, depending on how big your company is, to really think through, okay, what are the right approaches? What are the possible approaches that we could take on this? What are the most promising avenues to pursue? And then what source data is needed for that? It's almost like peeling the layers of an onion. You need to start with the problem, think through what kind of data is available, what kind of data is required, what kind of data is available, what techniques are best used. And then based upon that, and maybe doing some initial feasibility evaluation, really bring in somebody who is an expert in that particular domain. So, if you've got something that is very well characterized with a classical simulation model, then bring somebody in to do the classical simulation model. If you're doing something where you need to be able to scour publicly available data sets and use that for some purpose, say maybe using a diffusion model, you want to make sure you've got somebody who has expertise in that area. So I think that you definitely want to have people understand both the domain, not always necessarily the same people, the domain, the basic field, and then people who have experience in those specific synthetic data generation techniques that are likely to be applied here. And ideally, somebody who's done this a few times and has lived the pain of deployments that didn't go well, because there's no better feature than running into challenges like that.
Yeah, experience is the best.
It is.
Method of learning, right? What was the quote? There's no compassion for experience.
Yeah, that's right.
Yeah. So, yeah, I think it's great. I think, it also, even taking a step back to what data do you have on hand? What is it? The 5 B's of big data? I think it used to be 4, but now it looks like there's people saying 5. It's the velocity, the volume, the value of the data, the variety of the data, and the veracity of the data.
Mm-hmm.
Do you even have the data that you need to then begin to build synthetic data over it, right? And yeah, this is the kind of stuff all the way back to the beginning we're talking about, that if there's a gap in things like the volume of the data, well, now you can generate it, right? You're solving for individual pieces.
Yes. And so if you don't have enough data, where can you get that data? And then, all the issues around bias and accuracy and such, and you bring all of those in. What if you have to go collect the data? How long is it going to take? How much is it going to cost? These are there are maybe different alternatives to do this, but you have to think through all of this to be able to come up with a strategy for some time.
Yeah. What other thoughts do you have on it? I'm going to put a little marker down there. If anybody's watching and wants to put their questions in the comments, we see the questions live and we can respond to it, but we can't always put comments back into it. So for any of the viewers, feel free to ask some questions and we'll get to them.
Yeah, no, it's that. Thank you for mentioning that. I would just say maybe a couple of comments on what the different techniques are best at and not as good at. So, so we're talking about things like sample quality or realism. So, I'm kind of just going to rank them. I think if you've got deterministic simulations or procedural modeling, you're going to get the best sample quality, the best realism. There's no accidents that are going to happen there. Then you start getting into things like diffusion models are great for images, but not great for things like time series. GANs can be very good quality, but maybe very domain specific. So you need to make sure you've got those targeted the right domains. Variable autoencoders are not great for things like images because the output tends to be blurry and such. But for something like time series data, it's a really good fit. So it starts getting into those, the kind of quality you can expect for different sorts of usages. There's this question of training stability. So, and again, deterministic simulation or procedural modeling, there's no AI there, so there's no training. They're classical techniques, so they're not subject to that. But then you've got things like mode collapse problems or something, or training instabilities. Diffusion models are good, VAs are pretty good, GANs can go off the rails. Now, the good thing is you've gone off the rails, but the bad thing is you have to fix it and go back and do it again and spend more money to work on that. Speed, and I'll kind of combine both speed and cost. They're closely related. So, and again, the classical techniques can be all over the map depending on the complexity of the model. I would say that GANs and VAEs are generally pretty good. Diffusion models are slower and expensive, kind of like LLMs are slow and expensive. The question of how much data needs to be used to train things. So, and again, I think diffusion models tend to be fairly expensive on the amount of data you need. And then just the diversity, where I think where you're going to have the biggest problem with diversity is on classical models, on less, you have to explicitly specify all of the diversity you want. Whereas then I think with AI-based models, some of the diversity can come from both the source data you're using, the training, the hyperparameters and such that are used for training. So, but I think diffusion models tend to be good for diversity. Some of the other techniques can, again, kind of get into a rut a little bit. So I just feel like and this is where it's important to have somebody who really understands the nature of each. Not every method is right for every type of synthetic data. It's a matter of matching the right method or methods to the type of data you want to generate.
Yeah, that's great. And I think it also comes back to the overarching need. You need to know what you want to do, and what the outcome is that you're solving for, and what your strategy is, or the problem that you're really fundamentally trying to figure out. Like with all that, it's always, there's a lot of tools, a lot of techniques, and it's easy to get lost in the sauce. Right? You just don't know where do I even begin, and you got to begin with the problem. What is it that you're trying to solve for? And from there, just cascade down into more and more of the details.
Yeah, I could not agree more.
So, I didn't see any comments come up. I hope that it's just because we answered everything and not because we didn't go live. But we'll put the recording up. Any final thoughts before we sign off?
No, not really. Just thank you for the opportunity to do this. I think it's a super interesting topic. And it's one of those things that it's, I'm not sure what your perspective is. Maybe there's a name for that effect that when you become, when you start dealing with something, you start seeing it pop up more and more. But I swear, like the last 6 months, I've just seen an explosion of synthetic data references. It definitely seems to be, maybe that means we're on the front end of the hype cycle. I don't know, but I think synthetic data almost transcends the hype cycle. In reality, lots of people have been using synthetic data for years, just not necessarily calling it that. And I just think it is an essential tool in the toolbox.
I think that's important to know, right? Synthetic data has been around. We've all done the test data pre-production and we have to do it, and then we find errors in our data. So it's been around, but now it seems like it's coming to a whole new level. And we mentioned it before, just the overall market cap for synthetic data solutions is growing exponentially. And I think that's so cool to be able to create and run these agents that, will spit out IoT data, image data, whatever it needs, and get you the data that you need to solve your problems. I think it's awesome.
And get it in a very timely and cost-efficient manner.
Yeah, as long as you don't put garbage in.
As long as it's the garbage in. Exactly. That's the takeaway.
Okay, well, thank you very much for joining again. This has been great, and I look forward to continuing the conversation.
Likewise. Thank you, AJ.
Yeah.
Bye, everyone.
Take care.